Namaste students, welcome you all for today's maths class. Today we are going to see the cross product of two vectors. Okay, so if you take two vectors a vector cross b vector, their cross product is given by a vector b vector sin theta n cap, and you all know if dot product is equal to 0, then the two vectors are perpendicular. Here the cross product equal to 0 means then the two vectors are parallel. The third condition, if theta is equal to pi by 2. So if I put theta is equal to pi by 2 here, what will happen? Sin pi by 2 will become 1. So a vector cross b vector is equal to magnitude of a vector, magnitude of b vector. The next one, for these points, okay, you should know this order I, J, K. So you can see this cyclic order I to J, J to K. So the cross product of same vectors will be 0. See, you can see this, and the next thing is I cross J. It's a cyclic order. So I cross J means it is K. J cross K means it is I. The same way K cross I means it is J. So no changes in the value. But here you can see this J cross I, it is going in anti-clockwise direction. So the answer is minus K here. The same way K cross J. So minus I cross K, it is going in anti-clockwise direction. So the answer is minus J. And this is one more property, A vector cross B vector. If I want to interchange and write as B vector cross A vector means you will get a negative sign outside. And then you all know this angle between two vectors in cos theta, you all know, right? Cos theta is equal to A dot B by magnitude of A vector, magnitude of B vector. Here you have for sin theta. So sin theta is equal to A vector cross B vector by magnitude of A vector, magnitude of B vector. These are the properties you having in cross product, and we have some more properties also, that is area of triangle. Okay, if A vector and B vector are the adjacent sides of a triangle, then its area is given by half magnitude of A vector cross B vector. And this is also, if A vector and B vector are the adjacent sides of a parallelogram means then its area is given by magnitude of A vector cross B vector. Okay, the only difference is here we are not having half. The next one is how to find the cross product for two vectors. Suppose A vector and B vector. See, A1i, A to J, A3k, B1i, B to J, B3k means how to find the cross product means first you should write this ijk, then the coefficients of A, A1, A2, A3, then the coefficients of B, B1, B2, B3. This you should expand. The expansion we will see in the sum. We'll go for exercise 10.4. First sum, find magnitude of A vector cross B vector if A vector is equal to this, B vector is equal to this, and so you should find A vector cross B vector. So as I told you, the first step is you should write I, J, K. Then you write the coefficients of A, 1, minus 7, minus 7, 3, minus 2, 2. Now this step is very important. See, you can see the symbols on the top, right? Plus, minus, plus. Again will go minus, plus. The same thing, right? So now if I take I, it is positive. Can you see where I is lying here? This row and this column you should neglect, and what you are having here? Only these elements, which means, see, 2 into minus 7 is minus 14. In between you should have one minus always. Minus into minus will become plus. Okay, 2 into minus 7 is minus 14. Minus 2 plus 7 is minus 14. Minus minus will become plus. So minus 14 plus 14. When you take J, minus J, always J, the value for J is minus J. The same way you should neglect this row and this column. You can left out with this, right? 2 into 1, 2, minus 3 into 7, 21. So in between always negative should come. So 2 minus 21. So go for K, K you have plus. The same way cover this, wherever K is lying, that row and that column you should neglect. So minus 2 into 1 is minus 2, 3 into minus 7 is minus 21, but in between you should have one negative. Minus minus will become plus. So you are having this plus 19j plus 19k. They are asking the modulus, the magnitude value here. So magnitude of a vector cross b vector is equal to root of 19 square plus 19 square, which is equal to 2 times of 19 square. So 19 root 2 is the answer. Okay, this is the first sum, a vector cross b vector. Okay, the next one is find a unit vector perpendicular to each of the vectors. So what is a unit vector? You all know this formula, right? For unit vector, a vector by magnitude of a vector. Okay, so now we are going, but here it is given a vector plus b vector, a vector minus b vector, and they are given a and b value. So first you find a plus b, then you find a minus b, then you should find the cross product. Why we are finding the cross product here means, here it is given one vector is perpendicular to a and b. So this is a, this is b. Okay, this vector is perpendicular to these two means these two vectors are parallel. Parallel means, you know, you should use cross product. So a plus b cross a minus b. The same way I, j, k. What is a plus b value? You can see here, what is a plus b? 4i plus 4j. So 4 k value we are not having, so we are putting 0. So a minus b value is 2i plus 4k. So 2, 0 and 4. Now you should expand this the same way. First I put I. If I take I will cover this. So 16 minus 0. So j takes the value of negative. So minus j. We should cover this. Again 16 minus 0. If I take k, okay, cover this. So what will happen? 0 minus 8 to become minus 8. Then I should find the magnitude of this vector by using this x 16 square minus 8 square. So 16 square I can write as 2 square into 8 square, 2 square into 8 square plus 8 square. So you can take 8 square out of the root will become 8. So root of 2 square plus 2 square plus 1. So 8 into root 9. So 8 into 3, 24. This is your magnitude value. So you are going to substitute this unit vector formula. A vector here is a vector plus b vector cross a vector minus b vector, and magnitude of a value is 24. So we have substituted this, and this is a very important 4-mark question. Okay, so you will get the a, b vectors values will change, but if they are given unit vector perpendicular to each of the vector means, first you should find the sum, then you should find the difference, okay, depending on the question. Then you should find the cross product of those two vectors, then find the magnitude and substitute in the formula. Okay.